pleasant greetings to all. In this video, I am going to explain most important MCQs in analog electronics. Problem number 1. The circuit shown below represents option A OR gate, option B AND gate, option C NOR gate, option D NAND gate. 3 inputs A, B, C. All inputs are 0. Any one of the input is 1 and all inputs are 1. So what is OR gate? OR is the addition of all the inputs and multiplication of all the inputs. NOR addition and then take a bar. And NAND means multiply and take a bar. So these 4 gates are given. Now I am going to check. Okay, first of all I am going to apply the value. A is equal to 0 and B is equal to 0, then C is equal to 0. If 3 values are 0, this is cathode and this is anode. Anode is connected to the positive potential and cathode is connected to the negative potential. So the diode is in on condition. This diode is on condition and this diode also on condition. So here the current always take a minimum resistance path. So current is flowing to the ground in all the inputs like this. So what will be the output? The output equal to 0. So output these 2 are correct. These 2 combinations are wrong. And next I am going to apply 0, 1, 0 combination. 0, 1, 0 also. Here 1 is connected to the cathode and 5 is connected to the anode. Here it is in the open circuit. So open means open, but anyway the current is flowing through the ground. So what about this case? This case also will get the output as 0. But here output 1, this is the wrong. So which one is correct? AND gate is the correct one. So option B is correct. Problem number 2. The circuit shown below represents AND or NOR and NAND. AND means multiply both the input. OR is addition. NOR is A plus B the whole bar. NAND AB bar. Okay, here I am going to check using the values. First of all I have to apply A is equal to 0 and B is equal to 0. So both are equal to 0. This is not conducting and this is also not conducting. So the output equal to V0 equal to 0. And next I am going to apply A is equal to 1. So A is equal to 1 means the first one is conducting. First is conducting, so current flowing through this. So we'll get the output V0 as 1. So this is look like a OR gate. Here option A is correct. Problem 3. Assume the diodes are ideal. Find the values of I and V. V is the voltage across D2 and I is the current flowing through D1. In such type of circuit arrangement, at first sight it might be obvious whether none, one or both diodes are in conduction. So you have to make some assumptions here. Let us assume both diodes are conducting. So V is equal to 0. This diode is conducting means the ground potential is come to this point. So this is 0. And if this diode is conducting means the ideal diode, no. So ideal diode it is conducting. So what will be the value? Here there is conducting. It will be act as a short circuit. So V is equal to 0. The current through D2. How to find out the current through D2? Here the 0 potential in VA. So what is the current? 10 minus 0 divided by this resistance. 10 minus 0 divided by 10 kilo ohm. So that is 1 milliampere ID2. Then see this current flowing towards the junction. This ID2 also 1 milliampere that is flowing towards the junction, and this is the current. Okay, so I plus 1 milliampere, that is equal to 0 minus of minus 10 divided by 5 kilo ohm. I is equal to, here this is 2 milliampere. So 2 milliampere minus 1 milliampere, this is 1 milliampere. So what is the answer for current? Current I is equal to 1 milliampere. And what about the voltage V? V is equal to 0 volt. So option E is the correct answer. Next problem, problem number 4. Assume the diodes are ideal. Calculate the value of I and V for the circuit shown below. It is look like a previous problem. Here also the same assumptions I have made here. Both diodes are conducting. So both diodes are conducting means, what about VA? If both diodes are conducting, VA equal to 0 and V also equal to 0. See, this diode is conducting. So the 0 potential that is connected this point. So VA equal to 0. Here this is conducting. It will be act as a short circuit. V is also equal to 0. What about ID2? ID2 equal to, here there is 0 potential. So 10 minus 0 divided by 5. So this is the current ID. This voltage is 0, no? So 10 minus 0 divided by 5 kilo ohm, 2 milliampere. So this current is flowing towards the junction, that is 2 milliampere. And this current is also flowing towards the junction. I plus 2 milliampere equal to 0 minus of minus 10 divided by 10k. So that is 1 milliampere. What about I? I is equal to 1 milliampere minus 2 milliampere, that is minus 1 milliampere. So minus 1 milliampere, which is not possible. So this assumption is not correct. So we have to go for the next assumption. Assume D1 is in the off condition and D1 is on condition. So D1 is off condition means, is there any current flow here? This is look like a open circuit. So this is open circuit, no current is flowing. Okay, now ID2, what about ID2 now? ID2 equal to 10 minus of minus 10 divided by 15. ID2 is what? 10 minus of minus 10 divided by 15. So that is equal to 1.33 milliampere. Okay, then we have to find out the VA value. So what is VA? VA equal to, VA is not 0 now. I am going to find out the VA value. VA is here minus 10, and here is there any voltage? Here the voltage is here minus 10 plus 10 into 1.33. Okay, so that is 3.3 volt. Okay, that is the voltage VA. VA equal to 3.3 volt. So D1, if VA equal to 3.3 volt, D1 is reverse bias and the current flowing through is I is equal to 0. So option B is the correct answer. Next, problem number 5. For a given emitter current, the collector current will be higher. So emitter current IE is equal to base current plus collector current. Emitter emits the electron. So more current in the emitter, and collector that collects the electron before that passes through the base. In the base, some of the electrons are recombined with the holes. So very few, the 2% of current is wasted here. So recombination rate is less means automatically the collector current becomes more. So what is the answer? The recombination rate in the base region were decreased. So that is the correct answer. Next problem. The current ICBO is generally greater than in silicon than germanium transistor. B depends largely on the emitter base junction bias, depends largely on the emitter doping. D increase with an increase in temperature. It is increase. Current ICB not is increase and increase in temperature. So option D is the correct answer. Okay, next problem. Problem 7. The transistor is said to be in a quiescent state when no signal is applied to the input. It is unbiased. C. No currents are flowing. D. Emitter junction bias just equal to the collector junction bias. The answer is no signal is applied to the input. Next problem number 8. The most satisfactory LED driver in a circuit below. In order to reduce the power consumption, LEDs are always loaded with resistor. See, the option A and C, LED is loaded with the resistor. But which one is correct? Here, option A, LED current is supplied by the power supply. And option C, LED is supplied by the gate. But the correct answer is LED current is supplied by the power supply. That is the correct answer. Option A is correct. Next problem, problem 9. The basic purpose of the filter is to A. Minimize variations in the AC input signal. B. Suppresses the harmonics in the rectified output. C. Removes ripples from the rectified output. D. Stabilize DC output voltage. The answer is option option C. That is removes ripples from the rectified output. 10. The RC coupled amplifiers is also called an audio amplifier because option A speaker is connected at its input, B coupling capacitor couples the two stages, C it has almost constant gain in the audio frequency range, D none of this. The answer is it has almost constant gain in the audio frequency range. Problem number 11. Heat sinks are used with power transistor to increase the collector dissipation rating of the transistor. B. Increase the gain of the transistor. C. Increase the output power. D. Reduce the heat loss in the transistor. The answer is option A. Increase the collector dissipation rating of the transistor. Next problem. The BJT is said to be operated in a saturation region if both the junctions are reverse biased, B. Base emitter junction is reverse biased and base collector junction is forward biased, C. Both the junctions are forward biased, D. None of this. The answer is both the junctions are forward biased. Question number 13. Thermal runaway in a transistor biased in an active region is due to heating of the transistor, changes in beta which increases with temperature, C. Base emitter voltage VBE which decreases with rise in temperature, D. Change in reverse saturation current due to rise in temperature. The answer is option D. Change in reverse saturation current due to rise in temperature. Next problem 14. The forward resistance of the diode shown below is 5 ohm and the remaining parameters are same as those of an ideal diode. The DC component of the source current. Here the diode is act as the half-wave rectifier. So what is the DC component of the current? IDC equal to Vm divided by pi into RL plus RF. RL is the load resistance and RF is the forward resistance. RF forward resistance is given 5 ohm, load resistance is 45. Vm divided by pi into 45 plus 5, that is 50 pi. So what is the answer? That is Vm by 50 pi is the correct answer. So option A is correct. Next question, potential barrier. that act as a barrier against the flow of electrons only, flow of holes only, both electrons and holes, and none of this. The answer is both electrons and holes. Option C. Next, the input resistance of a common base transistor circuit is of the order of 0 ohm, 50 to 100 ohm, 100 to 150 ohm, 150 to 200 ohm. The answer is option B, that is 50 to 100 ohm. The output resistance of the common base transistor circuit is of the order of A1 kilo ohm, B10 kilo ohm, C 100 kilo ohm, and D is equal to 1 mega ohm. The answer is option C, that is 100 kilo ohm. Next question, a forward resistance of a diode will be very high, small, infinity, 0. So forward bias region, the current is flowing, it will be act as a short circuit. So the resistance may be very much small. So option B is correct. 19. Feedback regulators are used to provide high load current, then low load current, medium load current, and very low load current. The answer is option A, that is high load current. And next, 20. Best electronic device for fast switching is MOSFET, JFET, BJT, and diode. Here the MOSFET, the input resistance is very high, that is 10 power 15 ohm, and this will be act as a fast switching device. Option A is correct. Thank you. Have a nice day.